Hey guys, thanks for tuning in to the Algebra 7.3 video. We're going to talk about scientific notation today. But before we do that, I hope you guys are feeling good about multiplying and dividing monomials. You guys can go ahead and take a minute and knock out these 5 review problems, and when you finish up, we'll come back and talk about scientific notation. So scientific notation is just an abbreviation for numbers. So what we're doing is we're rewriting the same number just in a different way. So if the number is greater than 1, it's going to have a positive exponent. A positive exponent to the power of 10. But if the number is less than 1, then it's going to have a negative power of 10. So we got a positive and a negative. And when we're working with scientific notation, there's 4 easy steps for us to follow to rewrite these numbers. So we're going to move the decimal point until it's to the right of the first number, as long as it's a non-zero digit. Then we're going to count how many decimal points we moved it, and that'll tell us if it's a positive or a negative power of 10. And then we're just going to get rid of the extra zeros that we have left over. So we'll jump right in and take a look at our first example. So the first step we're going to do is rewrite our number. Oops, I already messed up. We're going to rewrite our number moving the decimal point. So we got 4.062 and then 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, and the next step was to count how many places we moved the decimal. So for this example, we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. So our power of 10 is going to be 12. And we'll rewrite this as 4.062 times 10 to the 12th power, because that's how many decimal places we moved it. So that's going to be our number in scientific notation. And notice we removed the extra zeros, and the extra zeros were only going to be the zeros to the right of our last digit. So we're not going to be removing that 0. So if we multiplied all of this out, we would get the same number we started with right here. So if we take a look at our next example, we're going to do the exact same thing. Count how many decimal places we moved it. 1, 2, 3, 4, 5, 6, 7. So this time we moved it 7 places from left to right. So this number is less than 1, which means we're going to have a negative power of 10. And since we moved it 7 spaces, we're going to have an exponent of negative 7. And that's going to be our answer in scientific notation. So our answer here is called scientific notation, but the first number that we started with, we would call this number right here in standard form, which we'll take a look at here in a second. So let's flip over to the next page and see on your own what you guys will be able to do. So example C is 458 million, and you guys need to write it in scientific notation. Now let's look at example D. Example D is we've been given the number in scientific notation, and they want us to express it in standard form. So we're just going to do the exact same thing, but we're going to work backwards. So we start with our 6.49. We're going to move the decimal place 5 times because we have the 5 as the exponent. So 1, 2, 3, 4, 5. So we're going to have to add in 1, 2, 3 zeros. So our standard form is going to be 649,000. And that's going to be our final answer. Now notice we moved it to the right because we had a positive exponent, but for our next example we have a negative exponent. So instead of moving it to the right, we're just going to move it to the left. 1, 2, 3 places. We're going to add in 2 zeros. So if we were to rewrite that in standard form, it's going to be 0.0018. And that will be our final answer. So you guys can go ahead and do example F on your own, and I'll move on down and take a look at our next example. For our next example, we're going to be multiplying two numbers that are in scientific notation. So in order to do this, we could rewrite each of them in standard form and just multiply them together. But since they both have a power of 10, we can just multiply our 5 by 2.3, and then we can multiply the powers of 10 by each other as well. So we'll start with 5 times 2.3, and we'll also multiply 10 to the negative 6 times, I'm going to erase this here, 10 to the 12th. Alright, so we'll be using the power rules that we talked about last week. And so we can do 5 times 2.3 is just going to be 11.5. And 10 to the negative 6 times 10 to the 12th, we're going to add the exponents together because they have the same base of 10. We'll be left with 10 to the 6th. 12 minus 6 is 6. And so written in scientific notation, we're just going to have 11.5 times 10 to the 6th. But if you look back at our question, they want us to write it in both scientific notation and standard form. So we're going to take 11.5 times 10 to the 6th and write it in standard form. So we're going to move the decimal place 6 times to the right because it's a positive 6. So we move it 1, 2, 3, 4, 5, 6. Use our zeros to fill these spaces. And we're left with 11,500,000. So that's going to be our final answer. Scientific notation, standard form. We can also use division with scientific notation. So if we look at number 3, we can do the same procedure, this time with division. So we'll divide 6.4 by 1.6. We'll also divide 10 to the 4th by 10 to the 7th. 6.4 divided by 1.6 is simply 4, and 10 to the 4th divided by 10 to the 7th, we're going to subtract the exponents because we're dividing. So 4 minus 7 gives us a negative 3. So that is our answer written in scientific notation, but we have to write it in standard form as well. So we have 4.0, and we're going to move the decimal place 3 times, but this time we're going to move it to the left because it's negative. So we're going to go 1, 2, 3, add in 2 zeros here, and so in standard form it's going to be 0.004. So that's going to be our final answer. Now let's scroll down and take a look at a real-world example. A local newspaper has a circulation of 150,000 daily newspapers and receives $1.2 million in advertising revenue per year. So they want us to express the newspaper circulation and the amount of advertising in scientific notation. So our circulation, they said, was 150,000. So we're gonna write out 150,000. And our advertising is 1.2 million, so 1,200,000. And we're just gonna rewrite these in scientific notation. So we're gonna move the decimal place until we have a number to the left of the decimal. 1, 2, 3, 4, 5. We get 1.5 times 10 to the, how many places did we move it? 5 times. And it's going to be positive because our first number was greater than 1. Now for our next one, we're going to move the decimal place 1, 2, 3, 4, 5, 6 times. So we have 1.2 times 10 to the 6th, and it's positive because our first number again was bigger than 1. So that's going to be our final answer for that one. But for number 2, they say the newspaper predicts its advertising revenue will decrease by 1/2 next year as more people get their news from the internet. So what will the advertising revenue be after this decrease? Well, if the advertising was 1,200,000, if they're saying it's going to be half of that, we're going to divide it by 2 and get 600,000. Then we can rewrite that in scientific notation by moving our decimal point 1, 2, 3, 4, 5 places. Get 6.0 times 10 to the 5th because we moved the decimal place 5 places. Now we could also do this problem a different way. If we start with the number we had in our last problem, 1.2 times 10 to the 6th, if we just divide 1.2 by 2, then we get 0.6 times 10 to the 6th. But this isn't properly in scientific notation because the decimal point is over here. But if we moved it to the right where it's supposed to be, then we'd be left with 6.0. But since we moved the decimal point from the left to the right, we're going to have to subtract one power of our exponent, and be left with 6.0 times 10 to the 5th, which is the same answer as we got when we did it the first way. So that's what we're going to be working with on class tomorrow. Thanks for watching, and I'll see you guys in the morning.